Demos la bienvenida a nuestra ponente speaker remote, a doctora Carla Saldaña, con el tema Creating Intelligent Environments, Theoretical Frameworks to Transform GIS into Digital Twins. Doctora, usted es libre de presentar, ya sea en español o en inglés, como usted guste, y tiene ahorita permiso para presentar cuando usted indique.
Muchas gracias. Yo creo que empezamos ya. Voy a hacer la introducción en español y después voy a continuar la presentación en inglés. Pues un gusto de estar en esta conferencia de GIS LATAM. El día de hoy voy a hablar sobre un tema que está justo en desarrollo, que me interesaría mucho recibir el feedback de todos ustedes. Pues soy Carla Saldaña Ochoa, soy profesora en la Universidad de la Florida, tengo el estudios de pregrado, los hice en Ecuador, el de la maestría en la Universidad ETH de Zurich y el doctorado también en la Universidad de ETH de Zurich. Pues el tema de hoy que voy a hablar se llama Creating Intelligent Environments, a Theoretical Framework to Transform GIS into Digital Twins. And in order to start this presentation, I want to talk about metaphors. So we understand each other because we share metaphors. Such metaphors are familiar because we have things in common, such as belonging to the same species, the Homo sapiens, or the fact that we live in a world where we experience the same laws of physics, such as gravity and magnetism. Moreover, we invent theorems such as the parallel postulate from Euclidean geometry to explain certain phenomena. For example, if I say that your ideas are parallel to mine, such as a statement will suggest that perhaps we share similar ideas. Similarly, we can articulate an analogy with the concept of balance. When someone says an economy is unbalanced, we will understand that the economy has assigned more value to one party than the other. Like these two examples, many more can be formulated since these concepts have been invented over time to represent certain phenomena that have occurred. So let's imagine a future in which generations of humans live in space colonies, whose lives are shaped by the geometry of a small sphere. This community will have different metaphors since they live in a different perspective of that of a sphere. So the metaphors that I just described, parallelism and balance, will not work in that environment. So to begin this presentation, I would like to share one metaphor that I think will help us understand the concept that I am going to talk throughout the presentation. And this metaphor is about intelligent environments and artificial intelligence. So in order to talk about intelligent environments, I think we have to have a holistic approach to define what they are. And I think we have to do it through theoretical research, digital and technological implementations, and how do we really see this bi-directional connection to the physical world. So if we're going to look at what we can do in theory, we see that there are two paths. The one is to define what is an intelligent environment and what makes it intelligent. And the other one is how do we create a protocol, or how do we make the difference between the existing ontological models that there exist so we can claim this as to be a new thing to exist. So if we think about theory in trying to answer the question of what makes this an intelligent environment, I propose to think of an intelligent environment as the one that hosts four features that are related to intensity in relationship to the amount of information with which objects are represented in this environment, immersion, which is the sensation of being in the environment related to the experience in this 3D environment, interactivity, which will allow users to manipulate their environment and the creation that they do in a reactive manner, and interconnectivity as to think of a real-time feedback from the physical to the digital and vice versa. So I think, and I propose to think that an intelligent environment is that this became intelligent, and intelligence is embedded in the system architecture itself. So to start thinking about this structure or a protocol and how can we describe an intelligent environment, let's first understand that our world is a complex and often inaccessible object of understanding. Therefore, it can only be described with abstraction. Throughout history, we have created apparatuses to abstract the world. such as maps and models. They reveal complexities in a synthetic, simplistic, and partial way. They also facilitate ways of handling what we have, but we cannot explain. The definition of the terms map and models is sometimes confusing as both have been used interchangeably. Therefore, to clarify the distinctions between them, it is crucial to establish how these terms will be used in our way to describe this intelligent environment. So today's maps are diverse and are always changing as they are created with artificial intelligence and big data. Because one map is not enough to describe the world, we now face the challenge of producing models from these new and changing maps, hoping that such models will be the result of a personal articulation or a background, simply as background introduction between human creativity and his or her exposure to a panorama or available information, which is captured in a map. So let's look at these three concepts. After the Industrial Revolution, the world was seen for the first time as an object. So we were able to see with the mechanical point of view of the Industrial Revolution, we saw the Earth as an object. After the internet in the late 1990s, we changed this mechanical point of view to a networked one, which such a vector that internet collapsed both ability to communicate and the capacity to record knowledge through time. And also it created this data repository, which right now it became this new currency. And this movement, or this data-driven movement, changed established practices from one that had limited resources to another one that can access plenty of data. So today, what we're experiencing is a new momentum where there are challenged to make sense. We are challenged to make sense of this large amount of data, to create personalized models, which we talked today in the morning about doing the transition between data to information and then information to to knowledge. And then knowledge is what makes our profession, or what will make our profession to move forward this networked world and this data-driven world to create a cohesive and a human-centered approach to any profession we have. So as I'm an architect, I like to go back to one of the first questions that was posed by Vitruvius in his books of architecture. He defined architecture as the art of joining things like bricks, modules, operations, data, etc. If this is true, then the act or architecture itself is still in development, and it can still be shaped and it can be reshaped by its practice. So Vitruvius in his book described an architect by introducing two notions, the raziocinatio and fabrica. He said the architect's knowledge is brought into being by fabrica and raziocinatio. So we become architects by mastering the raziocinatio and fabrica. Fabrica is the work whose form is in keeping with its intended purpose, and raziocinatio is the reasoning on how we make things, right? So fabrica is the work, right? The final output, and the raziocinatio is how do we create this final output. And he says that we need to have both in collaboration when we're thinking of producing architecture. So we can argue that raziocinatio is the reasoning behind how we join things to know how to do, and fabrica is defined as the operation of doing it. And this operation of doing can be done by a digital rendering, a treatise, a practice of construction, a virtual environment. And in this presentation, we're going to showcase some of the examples of this raziocinatio on how to create this intelligent environment. And we will use the Fabrica with some real world examples of how we created these digital environments. And to do that, this is the theoretical background. We're moving to the technological background. So in order to show you or showcase what we think about the application of an intelligent environment, which is transforming geo information systems or data sets into a digital environment or digital twin, I'm going to do it through a project that is called GIS Twin. So the GIS Twin project is a project that has collaborations with NVIDIA, Deloitte, and several colleges at University of Florida. So what we're trying to do here is that we're trying to correlate three specific data, or at least research focus. So there is housing, there is health, and there is hazards. So we're trying to see how much influence a particular hazard has on the built environment and on the health of the population living in the built environment. So all of the data sets that we have, they are all geolocated, which means that they can all be mapped back to a particular space. So how do we create this environment? The first thing that I said is that we have this human-centered design, which is that we have to define what are the three steps of our problem, right? So we need to collect hazards events. We need to collect housing, infrastructure, and environmental data. And we need to give a feedback loop with the stakeholder to see how this can be actively used and feedbacked to help the community. So what you see here in the next slide is what we're trying. So we did a systems model to understand if there is any correlation between the existing data sets that we have, and how could we really create a meaningful tool for community to make decisions based on the correlations that we found. And one thing that we want to emphasize here with the technology approach is that we want to also give the opportunity to aggregate data in a different way, so we can have a zoom in or zoom out approach to the features that we are making a correlation to. So what we use for that question is a unsupervised clustering that allows us to organize data that can't be shared freely because it has privacy concerns into a meaningful aggregation process, which allows you to get to a very detailed scale, let's say at the scale of the 5 meters, to then a greater scale at the scale of, for example, a neighborhood. So we wanted to break from the predefined scales that we have for data aggregation, which are census tract and zip code, because sometimes these aggregation methods have no spatial correlation or topographical relationship to the site. So we wanted to create a new way to aggregate this data, and this data to have this scale shifting approach. Right, so we're creating this 3D environment. We need to collect the data, we need to define how we're going to visualize the data, and then we need to create a web interface for community to look at this. So we arrived to this situation and we said, all right, if we're thinking about an intelligent environment, and we already said that immersion, right, the feeling of being there is quite important, we need to work with the data translation. And what is data translation? Data translation is a pipeline that helps translate mathematical models, which are quite accurate in simulating natural phenomena, into a more immersive, realistic approach. So what we're doing here is that we're taking the output of a numerical model and then transform that into a visualization that is leveraging our shifting of scales, which is the resolution of the building of the intelligent environment is going to be very detailed depending on where you're standing, and it's going to be larger or less detailed around yourself. And we're translating real-time data to immersive experience, which you're seeing in this slide. All right, we talked about the data aggregation methods, we talked about the data translation, and now we're going to talk about prediction models. So all of this is how do we create an intelligent environment through technological applications. And here what I want to talk about, this is a project that is outside of the Jackstone prototype, but it's working in collaboration with NVIDIA as well. So what we're doing here, this project is trying to create, and this is very much related to the question that we had in the previous panel about how do we capture human perception, or at least qualitative data that is not very easy or easily accessible for us to work with. So here is a website that we created using several AI techniques. So for example, we have a 500,000 data set of street view images, and we wanted to label those images based on how much of a risk assessment that we can do on the objects within these images. So here, what you're looking is a user navigating the website. So here it's looking at the image, and the image has objects recognized. Here, the user is asked, do you think this image is on a university campus? If you say yes, you can click yes. And then based on the objects that are recognized, could you please tell us why you think this object is a risk if a hurricane happened? So what we're doing right now, we are trying to collect human perception of risk, or at least identify what humans perceive as elements of risk on a georeference data set. And we have other information that is available for users to understand the context, such as population density maps. We have flooding information data, and we also have the DEM map, which is the digital elevation model. And with this first trial, what we did, we were able to kind of understand what is happening once you're thinking about objects at risk within a built environment. So the first thing that we see here is that when we ask people about how safe you feel, there is really let's say surprising that a lot of people did not feel safe on those areas. And what we are doing here is that we're trying to identify in the areas that they did not feel safe, what were the main concerns about. So for them, the main concerns were about the falling of a tree, right? That's the correlation that we have between elements and actions. And then as well, we are looking at the damage in and vehicles, for example, power cables, electricity. So all of the things that we kind of already understand as bringing risk in a flooding situation, they are all mapped to that is matched to a street view image that has a geographic location. So once we ran this experiment, we realized that it really didn't give the users kind of an immersive experience to how this feels when it's flooding. So we recently were awarded a project by NVIDIA and the AI Square Center at UF to transform our digital twin approach to start collecting this human perception of risk, because in a digital twin, you can run some simulations and you can run some AI models that can help you identify elements at risk and then complement that information with human or user experiences that will be collected through this platform. All right. The feedback flow. I think this is important because we create these tools, we invest a lot of resources, thinking and research on creating these tools. How do we create a feedback flow with the community, with the physical environment? And the way that we're proposing the feedback flow is by using an augmented experience. So how can we get the feedback from people, or at least communicate the results that we have? And this is through two, let's say, modes. The first mode is an indoor mode. So here you have stakeholders looking at this digital twin inside in a room, and then there is information that is being complementing whatever statement that has been found as a correlation between house, human, and hazards. Sorry, household and hazards. And then we have this other experience once you are outside. And then you can really play with the time frame of saying what happened in the Hurricane Ian in 2022 in this area. How many were affected? Is there any correlation that we've identified in our data processing, where we can see that there were more emergency entrance at the hospital or things like that? So this is the way that we're thinking. How do we create a communication flow with the community later once we have created this intelligent environment? So the application, I see this at different scales. So I think an intelligent environment can have the scale of the Earth, right? So this is a project by NVIDIA. It's called the Earth Project. And if you search online, you'll find more information about this. We can also explore this at the territorial scale. And this is a snapshot of the project that I just showed you, which is the JAX twin. And we can also explore this at the landscape scale. These are some snapshots of one of the design studios that I teach at University of Florida, where students are able to replicate and navigate Florida landscapes and bring their design projects to the site and test specific qualities like light, shadow, and even simulate flooding events. And then at the building scale, and I think this is the much more developed scale that we see there is, because here, for example, facility managers, they are very often, well, they are tasked to keep track of the life of a building, of the building life cycle. And if we can create tools that can help them see real-time data being plotted on a building scale, they'll be able to have a much more informed, or at least intuitive, immersive way to keep track of what's happening to the building. At the object scale, so this is just a simulation of what happened with the CPU and what happened when you activate the fan, how the fan is cooling the graphic card. And this is just a simple example to say you can apply this intelligent environment thinking through different scales. I wanted to emphasize that what I just showed you has been documented in some articles. I'm just giving you an overview of the articles that were published at the Shell Lab. Here's the QR code to the lab, so you can, as I said, you can always reach out. And if you have questions about projects or if you're interested for collaboration, we're always happy to collaborate. So the Sure Lab is as I said at the beginning of today, is a spatial human-centered AI research and experimentation. And our primary interest is on human-centered AI. And we have two main research areas. The first one is how to use AI for to empower creativity, and the other one is how to use AI for social good, working with large geographic or GIS data sets. We've worked in multidisciplinary research projects that are related with architecture, agriculture, urban studies, public health, structural design, disaster management. So we're not, let's say we are agnostic to the application, but we know what we're working on. So that's our kind of approach to the projects that we're doing. This is not myself only. So I have a group of students that work with me. I have grad students, PhD students, I have undergrad students and collaborators that are outside of UF. Just want to point out that this is a team effort, and I'm so happy and glad that I get to work with these people in a daily basis. So I wanted to be fast to give everybody's time to questions or to reflect on some of the things that I brought up today. With that, I would like to thank you. As I said, my name is Carla Saldaña Ochoa. Here is the QR code if you want to reach out or if you're interested in looking at the research that we do. Thank you.